Hello again. In this video, I'm going to go over this homework problem from 3.7. And so it says, for the following composition function, find an inner function where u is written as a function of x, g of x, and an outer function y, which is a function of u, f of u, such that y is f composed with g of x. And then calculate the derivative of y with respect to x. And of course, y here is tangent of 6x to the fourth. Okay, so essentially what we're doing here is we're taking this function y is equal to tangent of 6x to the fourth, which by the way is a composition of two functions, and we're going to find the derivative of it with respect to x. Now, anytime you take the derivative of a composition of functions, you should use the chain rule to find that derivative. And there's actually two forms of the chain rule. And I'm going to show you both forms, but in this particular problem, they're wanting us to use one of the forms, but I'm going to show you how to use both. Okay, so let me show you how to do this. Okay, so here's our function. And again, this is a composition of two different functions. And these are the two different forms of the chain rule. And the one they're asking us to use is the top one here. So I'm going to do that way first and then show you how you can use the alternate form of the chain rule. Okay, so to use this top form of the chain rule, what you have to do is you have to take the composition that you have, that you're trying to take the derivative of, and you have to express that composition in terms of its outer function and its inner function. And the outer function you want to write as a function of u, and the inner function you want to write as a function of x. So in this case, the way you would do that is you would say, all right, y, actually let's start with the inner function. You'd say you want u to be the inner function in this composition. So if you kind of look at this, this is a composition of tangent of x, and that's your outer function, and then you're substituting in for the x, 6x to the fourth, which is your inner function. Okay, so you want u to be the inner function, in this case 6x to the fourth. Okay, so that's your inner function. Now notice you do have it written as u is being written as a function of x. Okay, and the outer function y has to be written as a function of u. Now that we've defined u to be 6x to the fourth, then you can see that y is the same as tangent of u, right? Because 6x to the fourth is u. Okay, and that's called your outer function. Okay, so basically you start with this composition and you just write the inner function as you say, you call the inner function u, and then the outer function will be, in this case, tangent of the inner function, right? Tangent of u. Okay, and so you've expressed the composition in this particular way. Okay, if you're going to use this form of the chain rule, you have to express the composition in these terms first. Okay, and we've done that here. Now we're going to find the derivative using the chain rule, the derivative of y with respect to x. Okay, so according to the chain rule, it's the same as the derivative of y with respect to u times the derivative of u with respect to x. Okay, and so the first thing we're going to do is find the derivative of y with respect to u. In other words, the derivative of tangent of u with respect to u. And of course, the derivative of tangent of u with respect to u is secant squared of u. Okay, so that's dy du. Okay, and now we're going to multiply that by du dx, the derivative of u with respect to x. Okay, so this is u, and now we have to take the derivative of that with respect to x. And of course, to do that, you could just use the power rule. First of all, the constant comes outside the derivative operator, so the 6 is going to remain in front. And then using the power rule, you can take the derivative of x to the 4th, and you get 4x cubed times the 6. In other words, 24x cubed. Okay? So that is your, that's the derivative of u with respect to x. Now, by the way, this is called this piece here, that's called your outer derivative, dy du. So this is your outer derivative here. And this is your inner derivative, du dx. Okay, so then just to finish this off, you have to go back and substitute for the u. U is the same as 6x to the 4th. So this is really secant squared of 6x to the 4th. Okay, and then times the 24x cubed. Okay, so that's the derivative of this function, right? It's 24x cubed times secant squared of 6x to the 4th. Okay, so that's how you would do it using this form of the chain rule. Now let me just show you, you'll get the same answer. Let me just show you that you can also use this form of the chain rule. And of course, you'll get the same answer. Okay, so in order to use this form, this is the original function that we're working with. And we're going to think of it as a composition, right? It is. It's a composition of two different functions, and we're just going to explicitly write down what those two functions are. So in this case, we have to determine what the two functions are that we're taking the composition of. Okay, so f of x will always be the outer function. Okay, this one's called the outer function, and this one's the inner. Okay, and so f of x in this case, the outer function in this case is the tangent of x. And then the inner function, just like it was up here, is 6x to the 4th. Now notice, if I say f composed with g, in other words, f of 6x to the 4th, then notice that when I form this composition, I do get tangent of 6x to the 4th. Okay, so all we're doing is we're taking this composition and we're writing out explicitly what the outer and the inner functions are. Okay, once you've done that, then the chain rule says that the derivative of a composition, f composed with g of x, is f prime evaluated at g of x times, and this should be g prime of x. It should have a prime on it. Okay, so let's find it. So the derivative of tangent of 6x to the 4th is f prime of x. Okay, so here's f of x. All right, so I have to find f prime. Okay, well, the derivative of tangent of x is secant squared x. And then what I have to do is I have to evaluate this at g of x. So notice this is f prime, but it's evaluated at g of x. Okay, so f prime of, and then g of x is 6x to the 4th. And so notice that you get tangent, or sorry, secant, right? Secant squared of 6x to the 4th. And let me erase that. Okay, so now that's the outer derivative. Okay, and then now you have to find g prime, the derivative of the inner function. And of course, g prime is just 24x cubed. And now just to finish this off, you take your outer derivative, which is secant squared of 6x to the fourth, and you multiply it by your inner derivative, which is 24x cubed, and you get the same answer as we got before. Same thing, right? So you can use either form of the chain rule, and you will get the same answer. Now, in this particular problem, again, they wanted us to write it, the inner function u as a function of x, and then the outer function y as a function of u. And so they wanted us to use this top form of the chain rule. But I wanted to show you that you could also use this alternative form of the chain rule, and you would get the same answer. Okay, so I hope you found this video helpful, and in the future I'll continue to do some problems from this chapter and hopefully get a chance to look at some of those videos as well. Okay, bye-bye.